Hello everyone. I hope everyone are studying well. So we are discussing about second chapter 10th class acids, bases and salts. So up to ninth activity we have completed. That is about what do you observe when you mix acid or base with water. So today we are going to discuss about 10th activity, that is how to find the strength of acid or base. So how to find the strength of acid or base? So how to find means we are going to do an activity. So by that activity we are going to learn how to find the strength of acid or base. So let's do the 10th activity. So how to find the strength of acid or base? So let's see how to find. Yes, to do this activity first we have to take two beakers. Yes, let's take two beakers. After taking beakers, just place two graphite rods in each beaker. And these two graphite rods should be connected to a battery. And one end of the battery you have to connect a bulb. In this beaker also just place two graphite rods. And then you have to connect to the battery with the help of the wires. One end of it should connect to a bulb. Yes, so firstly you have to take a beaker. Yes, in that beaker you have to place two graphite rods. And here you have to take battery and here you have to place bulbs, and this is the wire. Yes. Firstly, you have to take 2 beakers and 2 graphite rods, and that 2 graphite rods should be connected to battery, and to one end of it you have to keep bulb. Yes, okay. So after that, what you have to do? You have to take 2 solutions. Yes, so in the first beaker you have to place HCl solution. In the second beaker you have to place acetic acid solution. Yes, so in the first beaker you have to place HCl solution, hydrochloric acid, and here CH3COOH, acetic acid solution. So when you take HCl solution in this beaker, what happens? Let's see. So here just take CH3COOH solution. Yes. So in one beaker you have taken HCl solution. In second beaker you have taken CH3COOH solution. So when you take this HCl solution, will the bulb glow? Yes. Yes. So bulb will start to glow. Why? Why? Because it is acid. So when you take acid, when it is connected to the graphite rods, to the battery, what happens means you will be seeing glow of the bulb. There is a pass of electricity. When electricity is going to flow in that circuit, you can see the bulb glowing. So when you take HCl solution, bulb will be glowing. Okay. So next in the second beaker we have taken acetic acid. So when you take acetic acid, will the bulb glow? Yes, there also bulb glow because it is acid. So when we take acid, we can observe that bulb will glow. There is a flow of electricity in that circuit. So in the both the conditions, in the beaker A and beaker B, if you observe, what will happen? Both the bulbs will glow. Okay. So when they are glowing, you have to observe the brightness of that bulb. Yes, you have to observe the brightness of the bulb. So if you observe the first beaker, A beaker will be having somewhat brightness and B beaker will be having somewhat brightness. So when you compare both brightness, which one is having more brightness means beaker A will be having more brightness. So why it is having more brightness than this B beaker? Because in HCl we are going to have more H plus ions. So when there is a presence of H plus ions in more quantity, we will be having more brightness in the bulb. Here we are having only less amount of H plus ions. So what happens here? The bulb brightness will be little what? Low. Yes. So here there is a presence of more amount of H3O plus ions. So when we are having more amount of H3O plus ions, the brightness of the bulb will be more. So here the H3O plus ions are less. So when we are having less amount of H3O plus ions, the glowing of bulb will be less. So based on this, we can say the strength of that acids. Yes, how we can say the strength of these acids means here we are having more amount of H3O plus ions. Yes, so when we are having more amount of H3O plus ions, we can say that it is a strong acid. Yes. Yes, and here we are having in acetic acid less amount of H plus ions. So when we are having less amount of H plus ions, we can say it is the weak acid. So the first one is having more amount of H3O plus ions, so it is a strong acid. And second beaker, acetic acid is having less amount of H3O plus ions, so we can say it is the weak acid. Yes, okay. So by doing these experiments, we can identify whether the acid is strong or weak. Okay. So now we have taken acid. So next we will see about base. So if you want to know the strength of base, on what base you can know? Let me tell you. So in acid we will see how much or how many ions it is going to have. Yes, in acids based on H plus ions we can say. In base you have to say based on OH minus. If base is having more amount of OH minus ions, then we can say it is the strong base. If it is having less amount of OH minus ions, we can say it is the weak base. Yes, so how we can say strong acid will be having more amount of H plus ions, and the base means it is going to have less amount, base means strong base means it is going to have more amount of OH minus ions. Yes, so which solution is going to have more amount of ions, that solution can be strong when compared to the other solution. Yes, so to know the strength of the acids or base is the one of the methods. So other method also we can use by we can use pH scale. By using the pH scale also we can know the strength of acid or base. So next let's see about the pH scale. Let's discuss about pH scale. So pH scale. What is pH scale? So P means potential. It is a German word. P means potential. It is a German word. The meaning of it is power. The meaning of it is power. And here H means the number of ions which are present in that solution. By using pH scale we can say the acid strength and the base strength. So here P means potential. Potential means it is nothing but it is a German word. The meaning of it is power, and H means the number of ions which are present in that solution. So who introduced this scale means Sorensen. Yes, this pH scale is introduced by Sorensen. Yes, okay. So for what it is used? Yes, for what it is used means it is a scale to measure the hydrogen ions concentration in a solution. It is used to measure the hydrogen ions concentration in a solution. Yes, for what we can use pH scale means it is used to measure the hydrogen ions concentration in a solution. Yes, so the number of hydrogen ions are present can be measured or calculated by using this pH scale. So how this pH scale will be appeared? So let's see its appearance. Yes, so let's see its appearance. It is going to have 14 numbers. Yes, we can also call this pH scale as a universal indicator. Yes, this pH scale can also be called as universal indicator. So how many numbers it is going to have means it is going to have 14 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, so based on these values we can determine the solution whether it is acid or base. When you are going to see the solutions values, pH values, when you are going to measure the pH value of a solution, if the value is 7, it is neutral. If value is 7, the pH value of that solution is 7, means it is neutral. Neutral means it is a salt. Neutral means it is a salt. If the pH value of a solution is 7, it is neutral, and neutral means it is nothing but salt. Okay. So if the pH value of the solution is less than 7, that means from 1 to 6, it is going to have the pH value of a solution from 1 to 6. It is acidic in nature. It is acidic in nature. Yes. So the pH value of a solution is 1 to 6, means it is having what nature? It is having acidic nature. If the pH value of a solution is from 8 to 14, 8 to 14 means it is basic in nature. Basic in nature can also be called as alkaline. It also can be called as alkaline. Yes. So if you calculate or if you measure the pH value of a solution, its value is 7, means it is neutral, it is nothing but salt. Yes. Okay. So next, 1 to 6, if the pH value of a solution from 1 to 6 means it is having acidic in nature. So next, if the pH value from 8 to 14 means it is basic in nature. Basic means it can also be called as alkaline. Yes. Okay. Again we will divide these natures. If you observe from 1 to 3 values of pH values, if you are going to get 1 or 2 or 3 value, when you are going to measure the pH value of a solution, it can be called as strong acid. It can be called as strong acid. Or if you are going to get the pH value of a solution from 4 to 6. From 4 to 6 means it is weak acid. It is weak acid. If you are going to get 7, it is neutral. Already you know. And if you are going to get value from 8 to 10, it is weak base or else weak alkaline. If you are going to get pH value of a solution from 11 to 14, it is strong base or strong alkaline. Yes. So the pH scale is going to have 14 numbers. So from 1 to 6, if the value of pH value of solution is 1 to 6 means it is going to have acidic in nature. If it is going to get, the pH solution is going to get pH value as 7 means it is neutral. And pH value of a solution is from 8 to 14 means it is basic or alkaline nature. Next. Again in detail if you observe, it is going to have different color appearance, and from 1 to 3, if you are going to get pH value of a solutions from 1 to 3, it is a strong acid. Yes. So 4 to 6, if you are going to get the pH value of a solution from 4 to 6 means it is a weak acid. If you are going to get 7 means it is a neutral. Neutral means it is nothing but salt. And 8 to 10, if you are going to get 8 to 10 pH value of a solution means it is weak base or else weak alkaline. And from 11 to 14, if you are going to get the pH value of a solution from 11 to 14 means it is a strong base or else strong alkaline. Yes, this is all about pH scale values, and some of the examples I am going to say you. So let's see some of the examples. So let's see the examples of this. So first example is HCl. So HCl will be having the color of red. HCl will be having color of red. So the pH value of HCl is 3. The pH value of HCl is 3. When you are going to get pH value of a solution as 3, so it is going to have what nature? It is going to have acidic in nature. Yes, it is going to have acidic in nature. So HCl will be appearing in red color and its pH value is 3, and when you are going to get pH value of a solution as 3, below 7 means we are going to have acidic in nature of that solution. So next let's take distilled water. Distilled water means it is a pure water which is not having any oxygen molecules in it. It is a boiled water. Yes, so distilled water will appear in green color and its pH value is 7 and it is neutral. Its pH value is 7 and it is neutral. We know when we get pH value of a solution 7, it is neutral. So next, NaOH. NaOH. It will appear in dark blue color or else violet color. Its value will be approximately 10.5. It is basic in nature. Yes, it is having basic in nature. So firstly I have taken hydrochloric acid. Hydrochloric acid solution. When I have taken hydrochloric acid solution, so here I got the color of red and its pH value is 3. When we get 3, it is a strong acid. So it is acidic in nature. Next, distilled water. So distilled water appearance is green in color. So green in color means it is going to have how much pH value? 7. So when we get pH value is 7, it is neutral. Yes, okay, neutral. Next, base, that is NaOH, sodium hydroxide. So when you take sodium hydroxide, we get the color of dark blue or else violet and its solution value, pH value is 10.5. Approximately 10.5. So it is a basic in nature. So to know the solution whether it is having strong acid or strong base, weak acid or weak base, we can use pH scale. By using the pH scale, we can know how much acid it is going to have. The strength of the acid and the strength of the base can be determined by using the pH scale. So let's see the next concept. So let's see about importance of pH in everyday life. In the importance of pH in everyday life, the first one we are going to say about plants and animals pH sensitive. Yes, plants and animals pH sensitive. So plants and animals pH sensitive means when we are going to see the rainfalls, so the rainfall's pH value decreases less than 5.6 means the rainfall's pH value decreases less than 5.6 means it causes acid rains. What happens? It causes acid rains. And this acid rain water, if it flows into the river, yes, when it flows into the river. Acid rain water, if it flows to the river, what happens? The aquatic animals which are present in that river may difficult to live their life. Yes, yes or no? Yes, here plants and animals pH sensitive means when rainfall is falling, if its pH value decreases, how much? Less than 5.6. If its pH value, it is going to decrease less than 5.6 means it is going to cause acid rains. And this acid rains water, if it flows into that river, the animals, aquatic animals which are present in that river, what happens? It is difficult to live their life in that river. Yes, yes, it is the cause we can see. And next, pH change cause tooth decay. pH change cause tooth decay. We all know about enamel. Yes, enamel which contains calcium phosphate. Yes, so the enamel which is present in our teeth contains calcium phosphate. Yes, it is the strongest material in our body. Yes or no? Enamel is the strongest material in our body, and this enamel contains calcium phosphate. Yes. So, when there is a bacteria in our teeth, that bacteria's pH value is going to decrease below 5.5, less than 5.5 means then it damages our enamel. Yes, so we know that bacteria which is present in our teeth, its pH value is less than 5.5 means what happens? It causes the damage to enamel. Yes, so it causes damage to enamel. So what we have to do? We have to clean our mouth properly after having our lunch or after having our meal. Yes, so after taking our food, we have to clean our mouth with the water. Otherwise, the bacteria will form. If the bacteria's pH value is less than 5.5 means it causes damage to enamel. Yes, so not only washing our mouth after eating, but also we have to do brush properly with our toothpaste. While you are doing brush also, you have to brush your teeth properly with your toothpaste. Yes, so these are the precautions we have to take to avoid the cause of the enamel. Yes, okay. Next. pH in our digestive system. Yes. pH in our digestive system. What happens? Let's see. So when we digest our food, we are going to release some HCl. HCl acid is released when we digest our food. Yes. So what acid we are going to release? We are going to release HCl acid. Yes. If the person is suffering from digestion problem, that person is going to release excess amount of HCl. So what we have to do? When a person is going to release excess amount of HCl means you have to give antacid tablets. Yes, antacid tablets, it is nothing but it is milk of magnesia. Yes, so when a person is suffering from digestion problem, what you have to give means you have to give antacid tablets. It is nothing but milk of magnesia. So when you give them, what happens? The person will feel relief. Yes, what happening here? Why that person is going to be relieved from that problem means here HCl is acid. It is going to be released when there is a digestion problem. So for that, to rectify that excess amount of HCl, what we are going to take? That person is going to take milk of magnesia or antacid. So antacid is base. Yes, HCl is acid. So to rectify this acidity problem, this acid, we are going to give base. What base? Milk of magnesia or else antacid. So what happens? The problem will be neutral. Already we know. Yes. Neutralization reaction. Acid plus base gives rise to salt plus water. Like so, here what happening? When there is acidity problem, we are going to use some base. So when you use some base, what happens? That problem will be rectified. It will become as a neutral one. We are going to neutralize the acid by using the base. Yes. Okay. Let us see the last one. pH in soil. Yes. The pH of the soil, how we can know? How we can know the pH of the soil means, just take a beaker. In that beaker, just take some soil. Yes, just take some soil and in that pour some water. Yes, first you have to take soil and then you have to mix that soil with water and then you just filter that one into the another test tube. Yes, into the another test tube you have to filter that one. After filtering that solution, just dip the universal indicator, the pH scale, you can dip into it. Then you can know the strength of that soil. So when you know the strength of the soil, what you can do? You can, based on the strength of the soil, you can take the best fertilizers. What fertilizers you have to use means, you can know by knowing the strength of the soil. To know the strength of the soil, what you have to do? Firstly, you have to take a beaker. After taking a beaker, you take some soil. In that soil, just mix some water. After mixing, just stir it well. After stirring it well, just filter it. So when you filter it, you have to filter into the another test tube. So in that solution, after filtering that solution, you have to dip a universal indicator or else pH scale. So when you dip the pH scale, you are going to get some pH value. So based on that pH value, what you can do? You can know the strength of the soil. By knowing the strength of the soil, you can use the best fertilizers. This is all about today's class. For more updates, for more videos, just subscribe to my channel, like, share, and if you are having any doubt, just comment me down.